Afternoon, everyone. Looks like we're just getting up on 2 o'clock now. I'm sure a few people will be joining here and there, but let's get started. First, I just want to say I appreciate your time this afternoon, especially since I'm sure there's a lot of different things you could be doing for 30 minutes on a Friday afternoon. But I think by the end of this webinar, you will see it as time well spent, especially since I really want to dive into the topic of PolyJet support removal, kind of taking a look at what are some of the most common support removal solutions that people are working with today, some of the biggest challenges they have with that, and then looking towards the post-process solution, how we've automated and made it an intelligent solution, and hopefully something that can resonate with you guys as well. So we kind of have a condensed window of 30 minutes. I don't want to go over that by any means, and we won't. So let's get started right now. So quick introduction, my name's John Streibel. I'm the Territory Business Development Manager over at PostProcess. I actually cover the Northeast Territory of the US and then also Canada. Today's agenda, I'm just going to do a very brief post-process overview so you know who we are, but then I'm really going to be spending more time on the next sections, which is today's support removal process. I'll go over some of the most common ways people are removing PolyJet supports today. Any of you that are PolyJet printing now, I'm sure these will really resonate with you, and you're doing most of those. I'll talk about a lot of the biggest challenges associated with that, and then I'll go right into kind of the solution that PostProcess has. This automated intelligent solution, how we've addressed those challenges, some of the key benefits, and then we'll look at some actual customer case studies. Customers who have actually adopted the solution and seen some of those transformative benefits in their lab and their post-print. And then of course, we'll have some time here afterward for some questions and answers. Feel free to ask me anything about anything, but I'm sure about your post-printing in your lab. If you have a certain application, maybe a certain part that you're thinking of, that'll be the time then. So let's hop right to it. Who are we? So at PostProcess, if you don't know anything about us, we are a company that is completely focused on delivering automated and intelligent solutions for that post-printing step in additive manufacturing. So when I say post-printing, I'm talking about the support removal and surface finishing of 3D printed parts. It's all that we do at PostProcess. It's our sole focus. It's what we eat, sleep, and breathe. And because it's our sole focus, we actually have solutions across all of the different print technologies. So today we'll obviously be talking about PolyJet, but we also have support removal solutions for FDM, SLA, clip, DLP. We have powder removal solutions for your MJF, your SLS parts. And when you look at the surface finishing side of things, same thing. Everything from your polymers to your metals to your thin and thick walled parts. So of course, when I talk about post-process, and that's our sole focus, kind of the next question I get with potential companies is, why is there a need for a company like post-process? Why is there a need for someone who's solely focused on that post-printing step? And the reason is, and I'm sure many of you are aware of this, and anyone who's been in the additive landscape for really any amount of time knows, when you look at the steps involved in printing, which is the design step, the build step, and the post-print step, the post-print step really has been one of the most neglected aspects of that equation. So, if you're looking at the design side with software like SolidWorks, then you go to the print side where you're printing with, something from Stratasys like PolyJet or FDM. Those technologies are constantly being updated. You're constantly getting software updates. The printers are constantly being able to print new materials, print faster, those types of things. And then when you look at the post-print step, people are either using, or the printer companies are recommending, the same solution that they've been recommending literally for decades. And more often than not, that solution wasn't designed for additive. It's something that's come from traditional manufacturing that kind of works at removing supports. So people have brought it over to additive. So it's not optimized to the process. And it's created one of the biggest issues of today, which is that bottleneck of the post-printing step, right? So if you're porting over something from kind of traditional manufacturing, not designed for additive, what we more often than not see is that it's a very time-consuming process. It's not usually very automated, so it's very hands-on, very labor-intensive. You get lower throughput, inconsistent results, oftentimes higher breakages. Again, these traditional forms of manufacturing, not designed for the materials of additive, not designed for the things you can do with additive, which is like prints, thin walls, complex geometries, organic geometries, real fragile stuff. That's why you often see these big breakages. And that's what led the post print to really become the bottleneck. And I see that as no more true than with PolyJet itself. So as you look at PolyJet support removal, there is really kind of two methods that the printer companies recommend. And as you kind of look out at the additive landscape, really kind of only two methods that companies are using. The first is probably the most popular, water jetting. I'm sure if any of you here are removing supports with PolyJet, you guys have one of these there at your facility. But if you're not familiar with water jet, that wasn't designed to remove PolyJet support material. That comes directly over from traditional manufacturing for different types of tool cleaning applications, metal tools actually. If you're not familiar how it works, you got a couple glove ports there that you stick your hand in. With one hand, you're actually holding a nozzle that's like a pressure washer, and with the other hand, you're actually holding onto the PolyJet part, and then you're just kind of blowing support material off as best you can. And in fact, most models, if you've seen them, they actually have like a little windshield wiper on the front there because water's getting sprayed up and splashing around. A little windshield wiper goes back and forth so you can see and get in there. Really just not a great solution, right? But it's the solution that's been recommended ever since kind of PolyJet has been around. And there's been really no advancement in that technology. And when you look at it, it's non-specific to additive, so you typically have a lot of challenges associated with it. Long, unpredictable cycle times, right? Every part tends to be a little bit different in the water jet. If it's small and it has no external geometries, it might only take a minute or two to clean. But if it has any type of internal geometry, you're looking at maybe 20 minutes, maybe 2 hours. I've even seen a part that I'll show here a little bit later that took 8 hours to clean because of the internal geometries. So very unpredictable. Obviously, it's a very manual process, right? It's one person in front of one part cleaning it. And traditionally, there's been a lot of tribal knowledge associated with that. When I go into different companies that have an additive lab and they're doing PolyJet, they typically have that water jetting guy, right? That technician or that engineer, and he's usually the one that's most familiar with how to use the water jet. He's kind of got that tribal knowledge of exactly how much pressure he needs, how far away to keep the part away from the nozzle so that it doesn't break and run his parts. And he's kind of the guy that you could show him a PolyJet part and he'd be like, oh yeah, that'll take me like 8 minutes or 25 minutes. And he has kind of all this tribal knowledge. And then of course, if he takes a sick day or you expand your lab and you get some other technicians in there and they have to run parts, cycle times are wildly different, right? They might double or triple. Your breakage rates go way up. And the reason for that is because there's just all this knowledge that an operator would have in this manual process. And that's why you get things like higher breakage rates, especially, excuse me, on those thin-walled applications. And then there's usually a significant labor cost, right? When we talk about one person in front of one part, whatever that technician or that operator is getting paid per hour, that has to go into the cost of the part now. And then lastly, cannot fully clean parts. This is a complaint I often hear from companies, when they're water jetting a PolyJet part and it looks completely clean, they'll take it out of the water jet and then they touch it with their hands. And there always seems to be this kind of waxy residue left. I've heard it called a couple different things, maybe that hybrid layer. It's just kind of that partially cured resin layer on the part that doesn't get off no matter how much you water jet it, and it just seems to always be there. So that's what I traditionally see out of water jetting. The other method that's pretty most common and usually goes hand in hand is just straight manual labor, right? Picks, brushes, dental tools. I usually see a mix of this and water jetting. I have run into some instances where just because of facilities requirements and things like that, they actually couldn't use a water jet. So they're just doing everything by hand with like dental tools and things of that nature. Again, very similar challenges that you see with the water jet, but probably even more to a high degree, right? Higher breakage rates, especially on those thin wall parts. Inconsistent results, probably even more so in this method. You know, if you have 100 of the exact same PolyJet part and they all go through the exact same technician for cleaning by hand, you will end up with 100 different parts by the end of the cleaning process. And that's just kind of the nature of manual work, right? There's going to be a little bit of support material left on this part where it wasn't on that part and things like that. And then also very time consuming, right? Probably even more so than the water jet because this takes a lot longer. So a lot of time is just tied up trying to clean these PolyJet parts. Now these methods and these challenges in the PolyJet support removal process, these are really the challenges that our founder at PostProcess saw and looked to address with our solutions. So we've developed automated and intelligent solutions for PolyJet support removal. And in order to have those automated and intelligent solutions, our machines are really made up of kind of 3 core components, and that's the software, the hardware, and the chemistry. That is really what makes us different from the other guys out there. We're looking at each one of those sections and designing something from the ground up specifically for additive manufacturing. So I'll touch on that a little bit here. But when I say hardware, here's a quick look at the support removal solutions that PostProcess offers. There's a couple different technologies here, whether it's a submersion system or a spray. And I'll note that each one of these machines can do any of the support removal processes you see up in the top right there. So any one of these machines can do your FDM, your SLA, your PolyJet, your clip, or your DLP. Oftentimes it's a different detergent, but it's the same machine. So obviously we'll talk about PolyJet today, and I'll actually more specifically be talking about the submerged system, the DEMI, and the 40. Those seem to just lend themselves really well to addressing some of those big PolyJet challenges that we just talked about. For sure, the DESI and base also do PolyJet, but for the sake of today's timing, we'll just be talking about that submerged system. So take a look at the 40 and DEMI here, and on the next slide, this is kind of the hardware behind the solution. So this is if you were looking at that DEMI and 40 and you cut it right in half, this is what you would see. So you basically have a tank that is filled up with a detergent, and there's a couple of strategically placed pumps that take your part and kind of float it through the whole submerged tank. You've got ultrasonics on the right, kind of taking that mechanical agitation to break up support. And then you also have a heating and cooling system as well. So again, this is very conducive and designed specifically for additive. There's a lot of different methods here to try and take away from having to do any type of manual picking, manual water jetting. That's where the temperature, the ultrasonics, and the pump come in. You know, once you put the part in there, they're kind of doing the manual work to remove those supports. So that's kind of the hardware aspect of the solution. The next up is the chemistry, the detergent. You know, very much different than what you see today. You know, more often than not, what customers are doing when they're looking at different chemistries to remove supports, they're kind of looking at what chemistries already exist out there on the market and trying to see what kind of works at removing supports for additive parts. At PostProcess, again, it's our whole focus is 3D printing. We actually have in-house chemical engineers that are studying and looking at the support materials that are out there. They're looking at the 705s, the 706, the 707s. They're looking at the FDM soluble supports, and they're saying, let's develop a detergent specifically to remove those supports. That's why we have special detergents for each one of the print technologies when we talk about support removal. So we actually have a detergent called PG1 that is specific to removing supports off 705, 706, 706B, and 707. This is what really helps us to optimize the solution, right? You have the hardware that's taking away that manual labor with the ultrasonics, with the heat, with the pump, so someone doesn't have to manually pick away parts. And then the detergent is in there, just eating away at the support material like it was designed to do, but not touching your part material. And that is one of the biggest reasons why when you pull a part out of our solution, it still doesn't have that kind of tacky hybrid layer that you often feel when you're water jetting, right? When you're water jetting or picking, you're just relying on that manual force to remove the support material. So there always seems to be some left. But when you combine manual force with some amount of chemistry, like our PG1, that chemistry is really what can eat away at the support material, so it's non-existent on the part when you pull it off. So you really are just feeling what that part material is. And then the last thing I'll talk about for our solution is the software. So if you recall, we talked about the hardware, the chemistry, and now the software. The software is really what ties everything together. This is how we get our automated and intelligent solution. So when I say intelligent solution, the software really is taking care of a lot of the background changes and variables and things like that. So when an operator comes up, there's typically just 2 or 3 settings he hits to adjust, and then he hits play and he can walk away. So you don't need that skilled technician, you don't need that guy with the tribal knowledge to run parts. Really, with some just very basic training, you can come up, start a cycle within just a few seconds. In addition to being easy to use by having those 2 or 3 adjustments and variables, you also have the ability to save and store recipes. So now, it could be someone's first day on the job and you just tell him to go run recipe part 506 or whatever you've named it. He can go up and with one click of the button, he's getting the same consistent support removal of the PolyJet part as the guy who's been there for 15 years running the equipment. And it's all because the software has this control to save and store recipes. And then the other big thing about the software is just the control over the different variables of the hardware, right? So when I talked about the submerged system, the DEMI and the Forte, I said it had ultrasonics, it's got a heating and cooling system, it's got a pump. The software really gives you some minute control over that. So you can control the ultrasonics from 0 to 100%. You can control the heat to plus or minus a degree Fahrenheit. You can control the pump on and off. And that is what allows you to process very thin wall parts without breakages and things like that. So if you got a thin wall part, something with internal geometries, you can dial down the ultrasonics, you can turn temperature down. Now you can run parts through and not have to actually sit at the machine and worry about them thermally warping or breaking or something like that. And at the same time, if you have a more robust PolyJet part, you can dial up temperature, you can dial up the ultrasonics, and now you have a little bit more force behind taking those supports off, but your part is more robust and can survive. And that's all thanks to this software, really tying the chemistry and the hardware together to optimize removing those supports off PolyJet. So I just want to give you a couple of more quick examples so you could see our solution works really well, whether you're doing 705 or 706 supports. You can see a couple of examples up there. Works well if you have internal or external geometries. Again, you're just using that chemistry to eat away at the support material, using that software to control the hardware. So if it's a real thin wall part, like the bottom right part you see there, you can dial things down so you're not going to get warping or damage. And at the same time, if you have a more robust part, like that one in the top left corner, it's got a lot of support material on it, you can dial up temperature, dial up ultrasonics, and fully remove those supports. So as you kind of look at the post-process PolyJet support removal solution, this is really kind of the main benefits you see over some of those traditional ways like water jetting and picking. The first one is probably fairly obvious, higher throughput, right? When you look at water jetting, when you look at manual picking, it's very much one person in front of one part. But with post-process, you can actually batch dozens, hundreds of parts all at once in the same cycle. And you're also getting a cleaner part by the end of it. And I spoke about that a little bit more. When you're water jetting, when you're picking, you got that hybrid, that tacky, that waxy layer left over. Not the same when you go through post-process, because you have that detergent that's specifically eating away at the support material, but not at the part material. The next one is advanced process control, right? That's just the software controlling the hardware and gives you the flexibility of running those fragile, unique, organic geometries without having breakages. But at the same time, you can dial things up like the ultrasonics and heat when you have a more robust part, and you can get quicker cycle times. And then, of course, minimize operator errors. It's just kind of the nature of automating the process. Once you have saved and stored a recipe, you're doing the same exact sequence of events over and over again. So once it's dialed in, you're not damaging any parts. There's no need for operator error because he's not touching anything. But of course, if you're water jetting, you're picking, things like that, it's just a different action every single time on the part. So I'm going to go through a couple of real life case studies that we've done with post-process with some customers. Hopefully I kind of gave you an idea of some of the bigger challenges that people are seeing when they're water jetting and picking. I'm sure if you guys are using PolyJet, you're very, very familiar with those. And hopefully you got a little bit of a better sense of what kind of this automated intelligent solution looks like from post-process. So these case studies are from some real life customers that are switching from those traditional methods to post-process and how it's changed their lab up. So this first one is from Johns Hopkins University. The parts that they were working with there in the bottom left, they're actually vascular models. They're about the size of your hand, and it's mimicking the veins in your arm. For this type of part, they do a little bit of testing for it. So they actually put a hookup on both ends there that you see, and they run a fluid to mimic blood pressure through this vascular model. So as you can imagine, there's a lot of support material on this part. It's a pretty fragile material, and you might not be able to tell from this picture, but that kind of like weird channel thing is completely open. So it's about 1 millimeter in diameter, and when you're building this part, it's just full of support material. And it's not a channel that's straight through. As you can see, it's got kind of this organic shape. It goes back into itself a little bit. It goes up and it goes down, and really is just a nightmare to clean. This specific part, Johns Hopkins wasn't actually even able to use a water jet because it was too much force on the part. So they were using dental tools, they were using brushes, and then when they got to that small millimeter diameter channel, they were actually using a little water pick and just like slightly squirting water in there and trying to remove out support material. The actual clean time for a part like this was between 6 and 8 hours per part. So it was really just a labor-intensive way to clean parts. I'm sure you guys who print in PolyJet are just looking at this and know it would be a nightmare. And I could imagine sitting here for 6 to 8 hours cleaning it. Johns Hopkins was fairly low volume. They were basically just printing one of these a week. But again, it was just 6 to 8 hours of cleaning. So it was just extremely labor-intensive. From this, they got a hold of post-process. They switched over to our desktop system that you see there, the Senti. Again, they're combining that hardware, they're combining that software, and really that chemistry to eat away at the PolyJet support material. In this case, because the channel was so narrow, we weren't able to fully get rid of all of the labor, but we got it down to less than 30 minutes. So they went from about 8 hours of complete technician time down to about 30 minutes. So we were really able to take out about 90% of that labor that they were seeing in using kind of traditional ways to remove supports for PolyJet. The next success story I wanted to show you guys is kind of on the other end of the spectrum. You know, Johns Hopkins was only printing about 1 part per week, and it took like 8 hours to clean. This is probably a little bit more indicative of what I see companies doing today. This particular customer was printing about 50 plus PolyJet parts per day. And I will say every once in a while, probably like once a quarter, they'd get these bigger jobs where they had to do 100 to 200 parts a day. With this specific company, they really had their dollar and cents down. They knew exactly how much they were paying for parts, and they had a really good working knowledge and understanding that hey, you know, every time someone touches one of these 50 plus parts a day, that cost per hour now has to get associated with the part that they're cleaning and touching. So as they looked at traditional water jetting, they're doing about 50 parts a day. They averaged it out and saw that it was taking them about 8 minutes per part. right? So they have a whole line of 50 parts. It's going through a water jet, and someone's standing there for 8 minutes cleaning each one. So they looked at how much they were paying their technicians an hour. They looked at how much consumables they were using, and they found that it was about $7.58 per part that they were creating. They switched over to our DEMI solution. That was the larger submerged system you actually see there in the bottom right. They use that hardware, that chemistry, that software. They are able to get down to about 6 seconds per part. So they were able to batch all 50 at once. They took about 4 minutes to put the parts in the actual machine, hit play on the recipe, and walk away. That averaged out to about 6 seconds per part. Taking out all of that labor from having to clean the parts allowed them to look at the cost per part to get to about 32 cents. So they're going from $7.58 to 32 cents. It was just, a perfect application, right? PolyJet is just so labor intensive that when you're able to remove that technician time from having to clean the parts, you just see a huge savings because you can take out that labor rate into the cost per part. So those were kind of two of the kind of extreme examples, I think, for PolyJet. For sure, if you're printing 1 or 2 parts and it's super labor intensive, there's definitely a solution with post-process to help navigate and get most of that labor out of the cleaning process. And then on the other end of the spectrum, you may have a part that only takes you a minute, 2 minutes, or maybe 5 minutes to clean. But if you're printing a dozen or hundreds of those parts, that's hours and hours of extra labor cleaning. So having the ability to batch parts is going to be a huge benefit. So for sure, there's a lot of different benefits for PolyJet. Like I mentioned, it's a cleaner part, things like that. But these are kind of the 3 higher level benefits that a lab will see from switching over to post-process. The first is consistency, right? If you're automating the process, excuse me, if you're automating the process, you're doing the exact same cycle over and over again. You can have 100 PolyJet parts printed, go through our system, regardless of who's running the machine, and you're gonna get 100 of the same parts out at the end. You're gonna have increased throughput because now it's not one person in front of one part, but you're actually batching dozens and hundreds of parts at once. And then finally, increased productivity. Your technician, your engineer, even you can hit play and then walk away. Go back to printing, go back to designing the parts, doing something more productive than just having to stand in front of a part and kind of do some of these mindless tasks of removing supports. So that's kind of everything I want to talk about with PolyJet. Hopefully that gives you guys a better idea of some of the bigger challenges. If you're printing in PolyJet, yes, you're not the only one. More often than not, people are using water jets and picks, and they have these challenges. That's why there's been such a shift and such a benefit to switching over to something like post-process, where you can automate and batch those cycles. So if you guys have any other questions that we don't cover here, or you want to explore looking at a post-process solution, feel free to reach out to this email here and get in touch with Javelin or through the phone number. One of the things that we are constantly doing at post-process is benchmarking. So maybe you like the idea of saving labor, you like the idea of hands-free, but you're wondering, okay, how much time can we actually save? Feel free to actually print out some parts and send them to post-process, and we'll actually benchmark them. We'll do some before and after photos. We'll show you which machine we use, how much technician time it took to set up the machine, and how many parts we could do at once. And that'll give you a better idea of how well it will fit in your lab. But that's all for now. This has got a few minutes here for some questions. Feel free to unmute yourself, or if you want to type in the box in the webinar here, I'll be reading that and can answer any questions. All right, not seeing anything come through the chat box. Anything else? All right, excellent. Well, we ended right around 2:30. I hope you guys found this beneficial. Again, if you have more questions, you want to talk about a specific application, you want to maybe send a part to post-process to get in touch, to get completed, reach out to Javelin and they can help coordinate that. All right, Thanks, guys. I appreciate it. I hope you have a good rest of your Friday afternoon. I'll talk to you later. Bye.